Hello, voice check, voice check. Vo- Cool, I think my voice is very clear. We'll get started. Today's live, we are going to do again problems. Cool. Let's begin. Focus on work. Okay. See, network delay basically. So you are given n nodes. So it's a problem. So we are given n nodes, right? So it says in this you are given 1 and then 2 and then 3, 1, 1 and then 4 and then 1 is there, right? So we are basically given these nodes, right? And it is a directed graph, right? So 2 is to 1 and all these edges are there with their weights, right? Now, where u is the source and okay, we will send a signal from given node k. Okay, signal is, so k is our source node and return the minimum time it takes to the signal to go to all n nodes. All n nodes. So basically, whatever is the sum right now, generally whenever there is a graph problem, right? So this problem is kind of finding the shortest path, right? From this node to all the nodes. I want to go here also, want to go here also, then I want to go here also, then here also, right? All the nodes. shortest path. Now, if it would have been BFS, the weight would have been equal, because if you want to find the shortest path, right, the weight would have been equal, right? Now here the weight is not equal. So DFS is generally depth first search when you have to find connected components or islands, right? Then it comes when we have to combine things. BFS when there is something like shortest path, stuff like that. BFS, and then when there is weighted things, we go to when there is weighted things, we go to Dijktra, what basically is, right? So it says that when you have two options from a given source, one, two, you have two options, right? You basically pick the smallest one, and once you picked it and you are going to explore it, you mark it visited, right? There could be like this, let's say this is the node, right? And like this. So there could be a case that this is one, this is two, and this is four, and this is 1, right? Now basically distance to this, right? So it would be 5 from here, but it would be 3 from here. So first Dijktra will put this 1 and x, then it will put 2 and y, then here it will put 5 because 5 and let's say z, and it will put 3 and z, right? First you will pick this, right? Then you will put others, but eventually you will pick this, and then this will be visited, so you will have not you'll have visited all the elements, right? So that is how Dijktra works. It's kind of a greedy algorithm where you pick the minimum first. Now, if there are negative edges, Dijktra fails, right? Now, if there are negative edges, Dijktra fails. That's why to replace Dijktra, there is another algorithm that comes into picture. It's called Bellman-Ford, I think. Bellman-Ford, something like that. So it's another greedy kind of a thing, but yet there's a logic concept behind this which I don't remember. So cool. That's it. So this we are going to solve using Dijktra. Now, as Dijktra is a greedy kind of algorithm, we definitely need a priority queue. So yeah, I'll solve it, right? And we need a distance of each because that will tell us whether Dijktra is of any use to us or not. Yeah. So I'll not waste much time on solving. I'll quickly speak and solve this problem. So first thing we have times given. What I'll do is I'll construct graph on from it. Kind of a scarce graph. So I'll use graph here. Sorry, agency list here. You can construct graph either using agency list or array, 2D array, right? So this is done. Then you go into time, basically your times, and then you do graph.get uh, time of 0, comma add new int time of 1, comma time of 2, right? So that is the another thing that you use, basically adding the edge from u to v, right? With time, with time t basically is our weight, right? Now once we have done this, right, we need to find the distance from our source, which is k, right? So we'll initialize all the distance. Say here is dot fill. For now, I'll say that okay, everyone takes maximum distance, right? Because we want to minimize this. Then we'll say that okay, distance of k to k, right? The distance to reach news will be 0, right? Once you have done that, then you need a priority queue now, basically, to help you find which will be your next element, right? I'll call it PQ here, priority queue. Now here it is important that it has A, comma B elements. These are the two elements of the priority queue, and it wants to return the shortest of it, right? We are going to use node and then the weight. So this is going to be A1 minus B1, ascending order. So that is our priority queue. Now we'll add elements in the priority queue, our K and 0. Now while PQ dot size is not equal to 0, right? So do I need a size thing here? Like, do I need to traverse each element at a level? In Digitara, you don't need to do that because you only are concerned about the first element. So int at is equal to pq dot poll. So if I also need to know all the elements that are explode, right? I call it explode new asset. Now, uh, basically, if explode dot size is equal to n, then whatever time that you have taken as of now, right? So you need a int time variable. Whatever time that you have taken for now is your answer, right? Return time. Otherwise, let's say you still need to explore more thing, then you say that time plus is equal to at of 1, right? This is the time it takes to reach this. Now you want to traverse all the edges of this, right? So we start from 2, we'll explore all the edges of it. So for int 2 in graph dot at of 0, at of 0 is basically our node, right? So we are going from that to 2. Now here there is already a distance of reaching 2, right? If distance of already reaching 2, right, is greater than, you reach this using at of 1 plus you say that whatever is the distance between these two nodes, right? If that is the case, then this is your new thing, right? Then you say that pq.add new int, basically your at of 0, and then your distance becomes at of 1. That is the distance it is taking to reach there, right? Then at of 1 plus 2 of 1, right? And then you do this also, right? Now once you have done this, you have updated your distances, and here you add also explore.add at of 0. So in the end you return time. So this, you are basically picking all the minimum distances. Okay, 2 of 0, at of 0 is correct, k is correct. Okay, so basically here 4 nodes were there, but those are not 0 indexed. So what I can do in this case is, I know that I will never hit, so I can make just the distance plus 1, right? but other nodes also I'll have to make plus one. So I can think of them as zero based. That is one solution. I can think of all these as zero based. Zero based. Okay, let's see. Here the expected output is -1. So basically you did not explore all the elements, right? You went from 1 to 2. If explode dot size is not equal to n, then you return -1. Otherwise you return time. That's a good case. Handling each case. Okay. Okay, let's see why this failed. If explode dot size is not equal to n, right? Then that answer is -1. Otherwise the answer is time, right? You add elements in explode. So first you come here, you have already added k minus 1. Yeah, that doesn't matter. So you've already added here. So you have already added in this example, right? We'll take. So you already added 1 comma 0, and then you say that okay, you pop that out of PQ. So basically you have 1 comma 0, whether you explode now. So you add time and then you put explode. So your explode has 1 in it, and then you go to all the neighbors of 1, right, which is basically 1 and 3 that you have filled here, right? Time 0 u 2 v, right? And then your time remains same. So then you say that okay, distance of 2, which is basically a very big number, you say that whether it is greater than at of 1, which is as of now 0, and then you say that 2 of 1, 2 of 1 is 1. So yes, it is. So you make that and then you put at of 0. No, no, no. Why at of 0 here? So you are going to 2 of 0, right? Why at of 0? The next element that you're going to do is 2 of 0. And then what is the sum? Whatever you took to reach here plus whatever cost it is going to take further, right? So now, okay. So once you do that and then you say, uh, once you have done that, you put in Q you have put 1, not 1, that is 0. In Q you put 0 comma 1, and you basically do the same thing for 2. From there it will take one distance only. To that side also it will take one distance. So I think this time will be math.max. Not, it will not always be plus. So this time will be math.max. Because see, it is here, right? It takes one to go to this side, one to go to this side here. That's why you can either use BFS or You don't need the summation, you need the sum, right? Sorry, you need the max. So you don't use BFS. You don't use BFS, okay? The BFS is when it comes to weighted edges. Cool, and add this question to our description. Network delay time. Network delay time. Yes, so this is pure Dijitra. Hmm, Now I want to see. I don't want to solve problems. Okay, let's. This I know there is a caveat in this problem. Minimum cost, area, and dictionary. Probably I can try all these five and call it a day. That would be one thing to do. Uh, I also want to look at these interval problems, which are basically very easy, but I have not done them in a long time. Right, and then these bit manipulation, still good to do on your easy day. I also want to do some problems around the so let's see. Yeah, Trajectory, so many problems are there. Let's first, uh, let's solve this problem. Cheapest flights within K stops. One second, let me check. Hmm, Hmm. So there are n cities. So basically we are given n cities, and you are given an array of flights. So flights is basically from U to V, and there is a price. Okay, indicates that there is a flight from city U to V. There is also source, destination, and K. Source, destination, and K. Your aim is to return the cheapest price from with at most K stops. So if it was just cheapest, right, then this is just finding shortest path from source to destination, right? And that would be given by the Jitra itself, right? Now the caveat here is that you need at most K stops, right? Whenever you bypass that K stops, you ignore that thing. If it is within K stops, you don't go further basically if you have taken more than K stops, right? So that is how it would work. That is one way of doing this. Like plain Dijikra plus taking K so that it tells you how many stops whether you have taken. If the stops are more, then you basically can't consider that route, right? So we'll go with that only. I think because source to destination is Dijiktra, so we'll see how it goes. And our flights are basically four. These are zero based. That's a good thing. And we need to find the shortest distance, right? Basically. So now I'll think that I have a timer. I want to implement this very fast, right? So we'll go fast. So list integer graph is equal to new array list. This is going to be my graph. Graph dot add new array list. So once I've added my elements in my array list, now the next thing is I want to go to flights. So int from is equal to flight of 0, int 2 is equal to flight of 1, and int cost is equal to flight of 2, right? So graph dot get from dot add new int 2 comma cost. So I don't really need to do this, but still, like I don't need to do this part. This I have to do anyway, right? Now, once you have done that, you need a distance array also, which will be an arrays dot fill distance with integer dot max value. Now here you know that the distance of my source from its source is 0, right? Uh, Now when I make a priority queue, right, I need a third variable. PQ is equal to new priority queue, but I'll still keep the deciding factor as second. This is my cost factor, right? Now I'll do PQ dot add new int. So basically we need stops, right? So when you are at 0, then if you reach here, basically you have taken one stop. That is one. So basically when you're starting, you have 0 stops. So you can't, so you have to reach, I think 3. So this is the path to go, right? Because otherwise you can go like this, but that is like 1, 2, 3 stops. So you are at source, your distance is 0, and then you have taken 0 stops. Now while PQ dot size is not equal to 0, again we are only concerned about our current where you are, right? Now if add dot 0 is equal to destination, voila, you have reached. And your whatever cost that you found here to reaching here is your answer. Now, now you want to go to right? Graph dot get at of 0, right? All the two things of this. Now, first thing that you need to check is if already the stops that you have taken, because now you're going to get on a new flight, right? So this is going to count another stop, this place where you are at. If your stops are already K, you basically continue from there. If stops are already K, right? So you continue. No more stops you can take. Now, if distance to reach this node where you are at currently, right, already is greater than, if you can try coming from there, whatever distance that has plus distance of this, basically how much is this link, the cost of reaching here plus whatever is this link, right? So not graph, eq dot add new int. Now your at is you want to go to 2 0. Your cost will be at of 1 plus 2 of 1, and your stops will be increased to whatever stops were there, which is at of 2 plus 1, and this should not be greater than that. So at of distance of 2 of 0 is equal to at of 1 plus 2 of 1, right? And then you return -1. This means that you could not find anything. And also, I need to make sure that I'm not visiting. Like there could be circles, right? I'll go to 0 to 1 and 1, and then but 0 is already explored, right? So I need a visited map also. Visited, that means that you have already gone there, right? So visited dot add at of 0, and it should not be there. And visited dot contains 2 of 0 is false. So let's run it. So wrong answer, that's okay. So -1, 500 and -1, right? Let's see why this is -1. So if add comma 0 0 is equal to destination, I added PQ, that is 0. So basically you get, I have added, right? Yes. Basically you get your at of 0, which in this case is 0 can go to 1, 0 can go to 1 only basically. So that is your, and then, so if distance of to 0 is greater than at of, distance of to 0, hmm, hmm. So basically you are taking this flight. So your at of 2 is 0 initially, right? It becomes you have taken one stop and reached here. And then you go to, then from there you will take 3, and then it's 1 only, right? Still 1. So you have two options from 1. You can go to 2 or you can go to 3 also. For 3 you'll say that okay, distance of 3, no, it doesn't contain. Hmm. There is some typo somewhere because this should work. Hmm. Hmm, 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 hmm. Hmm, hmm, hmm. From to cost and test. So in the first one, it means it is never reaching that point, is it? How is that possible? Hmm. Okay, let's see. System.out.println arrays to string. Right. You start from 0, 0, 0, which is correct. Is the source 0? Yeah, source is 0. And then you go to 1, right? Then you say that okay, this is not, neither of this is true, so you go into the loop at of 0, which is basically 2, so that is 101, and then you go to 101. So from there you go to so let's do one more thing here. Out of 0 plus arrays dot to string 2, right? There is going to be a silly mistake. So from 0 you are going to 100, right? But why isn't 1? Is at of 0 is equal to k? No. Oh, k is just 1. This means one stop means 2 flights. So I'm thinking about flights. Okay, plus 1 I can do. Yeah. So I'm thinking about here number of flights that you have taken. Here you have already taken, this is already at most k stops, right? This is only one stop, but these are 2 flights. This is no stop there. If you go further, then it counts as a stop. Mhm. What is the problem? It should work, right? Why is the restricting output still there? So output is coming 9. Let me check. So you have flight 0 to 1, 5, 1 to 2, 5, 0 to 3, 2, 3 to 1, 2, 1, 2, 4, 1, and 4, 2, 2, which is again 1. So you need 0 to 2. So stops you can take 2. So flights basically you can take 3. Right? Hmm. This is one stop, this is second stop. First one we'll consider, right? Okay. 0 to 2. So start from 0. Answer would be 2, 2, 1. That is first option. The other one is 0. I think 1 you are reaching via 4, right? So we are not exploring this 5 option. But then once you are reaching 2, so it is 2, 3, 5, 1. Right? Then this goes away and you put 4, sorry, this is 2, 3, 5, 1. And then this goes away, you put 4, 1. Right? When you pick 4, 1, and you put 9, 2. Now you will pick 5, 1 only, right? So when you put 5, 1, you put 10, 2, and you put 6, 4. Then you will put 6, 4. Then you put 7, 2, 9, 2, 10, 2. Right? Your answer comes 7. Right? Which is correct. How many stops it has taken? 1, 2, 3. 3 you can take, right? Stops are 2 only. 1, 2. That is the final destination. So basically, zero, 0, 3, 2, 1, 5 is there, right? 1, 5 is there. Then you take, then you go to 3, 2, you pull it out, right? Then 3, 2 will put in 4, 1, right? Then 4, 1 came out. When you popped 4, 1, you will put 9, 2, and 9, 2, which is a very big element, or and you don't have any other place. So you will pull out, now you'll pull out 1, 5. Correct. So once you pull out the 1, 5, you will put in, so once you have pulled, 4 comma 5, right? So the next element of pull out is 4 comma 5. But how come the number of that is 0? 1 comma 5 was 1. How come 4 comma 5 is? I think so. You can already put it in a hash map, right? See, the thing is there is 4 comma 5 comma 3. How is that 4 comma 5 first of all? It has to be 4 comma 6, right? Of 4 only one way is there to reach 4. It has to be your, this is 4 and your at of 1 plus 2 of 1. What is at of 1? At of 1 is already 1 comma 5, right? Let's do this also. So when you are 151, right? So you can go to, you are at 1, you can go to the distance, or you can go to 4 with distance 1, right? So you will put 4 with distance. What is the distance? That is 1. How come this distance is 5? This has to be 6. Why is this 5? It's a separate thing. The distance to reach 4. What is the distance of 1 to 0? What is the distance of 1 to 0 in this case? 1 to 4 is 1 only. Damn it, where is the mistake happening? So you are at a 2, you are at 2, right? Then 2 of 0, you go from 8 of 1 plus 2 of 1. That won't do anything. That is not the issue. The issue is that you are at 151. 151. Cost is 5 and you have taken plus 1. You can go to 2 with 5 or you can go to 4 with 1. Right? You are saying that I'll go to 4, which is 2 comma 0, with at is 1. What is at of 0? At of 0 is 5. It is 2 of 1. 2 is 1. So it is going to be 6 only, right? This is 1, 4, 1. There has to be a silly mistake somewhere. So you have taken 1, 4, 1. You are at 1 comma 5, right? So basically you are 1, 5, 1. No doubt about this, right? You never enter this. Why you don't enter? How come you never added 2 into your PQ? You are saying that I can go to this 4, but I never popped it out, right? Never popped it out. If you don't have that, basically you will keep on rotating in a circle. But I never popped it out. Okay, this is getting scary now. So you are at 1,5 and you say that okay, I can go to 1 or I can go to 4, but I never go inside it. Why? Because distance to reach there, distance of 0. What is the distance of 8? Distance of less only. This, oh, this is, oh, because this is also 5, that is going to be 6. Damn it, damn it, damn it, damn it. Okay, so this is going to be 2, 2, because 4 you are already going via that, right? You have already said that I can go via that. And here it is coming as 6. Now how to work that? Okay, basically, but the stops you have taken are more, right? But you can't do this then. You can't update. Basically, you need a key also. With that distance with those key. So you need a key also here, I think. Oh, see, with 3 stops it is 5, but with 2 stops it is 1. Hmm. Yeah, see, the key is also the factor. Still wrong. Now why is it wrong? Mm-hmm. So basically the thing is that there are more greater than elements. I see. Took me way more time than expected, but I got this. We'll take a we'll take 5 minutes break. Okay, back to coding. So what I would like to do is, since I've recently solved these three questions I've recently solved, so I don't want to solve them again. It would be boring. Okay, so I did a filter. Let's see how my voice looks now. Is it better or is it still the same? Testing it myself. Uh, so the problem that I'm planning to solve is two graph problems I want to know. All pair shortage algorithm that you and then it is still the same. Remove filter and see noise suppression. Okay, yes, close. I think now the voice would be better. Maybe. Let's see. So Floyd Warshall, right? So Floyd Warshall is all pair shortage. So just like we saw Dijitra, right? Mm, yeah, it is better. Floyd Warshall is all pair shortage path algorithm. that uses dynamic programming to find the shortest distance between every pair. So earlier we were finding shortest from U to A, B, C, D, right? So this finds U to A to, so this it finds, but it also finds A to U, B, C, D, like each pair basically, right? And that's why it is a very easy to understand algorithm. So suppose we have a graph with V vertices, so V nodes from 0 to so the idea going forward, so we have to know distance where distance I represent the shortest path from vertex I to j, correct? From each vertex basically. Now let's assume that I and j have intermediate nodes, like nodes between the idea between point to each and every vertex is an intermediate node one by one. When we consider vertex k, we must have vertex k. So all the intermediate paths and all the intermediate paths too, right? And so we take k in between them. So pick all the so set add all the vertices one by one to the set of intermediate vertices. So first we have k, right? K is 0. So for k as 0, you will traverse all of the elements. So we'll say that if there is an edge, right? If I of j is equal to -1, I of j is equal to -1, or I of j, this -1 thing is wrong. This is not required. So I want to do two subproblems. Let's solve this one. Mm, This is the first problem. The second problem. The hint is already revealed, right, that these are based on third version, but it kind of takes the charm out of problem, but still will try to do our best. So let's see what this problem says. So you are given two indexes, source and target. Okay. Both length you are given also indexed original and change. And also the cost, right? In one operation, you can pick a character X from the string and change it to character Y at. So in one operation, you can pick X. Okay. So basically this will help me find the shortest path between this A to B, right? So that is the whole idea of it. So let's say long. Uh, so distance, right? 26, 26, right? Now initially, if there is no match, then that's the maximum distance, right? For long B in distance, average dot fill B with uh, long dot max value, right? Assuming that there is none. Now for I is equal to 0, I less than original dot length I plus this, right? Then basically this is my graph actually. If there is none, that means there is no edge, right? So you can't basically go from there to that. Right now, the graph, not just graph, but yeah, it is a Floyd Warshall. That is what going to happen here. This is graph, then we'll convert it into Floyd Warshall. So original dot caret I uh, changed dot caret I, basically the distance between this and this is this. Right now, I'll apply Floyd Warshall to get the minimum out of it, right? Because A to B, then B to C, right? So I can eventually get what is the distance from A to C, right? Apply Floyd Warshall. And there could be minimum also. So I need to do math dot min of. So this has to become graph of the same thing. Like this, right? So then what I will do is for and I is equal to 0, I less than point is equal to k less than 26, k plus 4, and I is equal to 0, I less than 26, I plus 4, and j is equal to 0, j less than 26, j plus. Now here, if it is already maximum, that means that there is no edge between them, right? If there is no direct edge between them, then there could be a edge, right? If depending on what this I and j uh, take through us. So basically, graph of I and j will be math dot minimum of graph I and j, comma graph I, comma k plus graph k, comma j. So that is the case basically here. Now the thing there could be that these could be both big elements. Let's say these are not linked, so that's okay. Uh, it will still remain the integer dot max value, right? This long might overflow, that's why I'm making it integer back. Now, now we need to convert, right? So for long answer is equal to 0, for time is equal to 0, I less than source dot length I plus char s is equal to source dot char at I, t is equal to target dot char at I. Now if uh, graph of s minus a So t minus a is less than integer dot min, right? That means that there is edge. Is greater than equal to, then you return minus 1. It is not possible. Otherwise, you say answer plus graph dot s t minus a return answer. So this is the one where I applied Floyd Warshall. So graph regional char mat dot min graph regional dot char at minus, what is the issue there? This is right. Graph is 2D. What is the issue? Yes. Dependency. This is the issue. Graph original. Okay. Sorry. This is why it is always helpful to read the format. Minor mistakes here and there. Okay. Okay, so basically A to A also is 0, right? So here we might not be considering that. So I need to make that change also. Uh, if S is equal to T, then you just continue. Yeah, cool guys. So this is how this problem can be solved. Let's copy this. In the city with smallest number of thresholds, there are any cities. So from bi-directional edge, determine the city with the smallest number of cities that are reachable through some path. Whose distance is at most distant threshold. City with the smallest number of cities. Okay, this hello and letter and okay guys, that's all for this stream. I'm going to end it now. Mm, So, mhm, thank you. This one. So, fine now, what do you guys say? Shall we solve some small problems? Yeah, we can do that actually. We have seen these problems are already solved. So let me solve this. And I think this one is premium. So both are premium. Okay. Non-overlapping intervals. Non-overlapping merge intervals. Meeting room. Let me see. Mm, Viewpoint priority we also want to solve actually. Margin questions of viewpoint priority. So these are the questions, right? And medium from interesting. Very famous question. Last one, key closure point, key largest element in an array. You can probably do all of these. And then it will be a refresher for me. What do you guys say? But I wanted to stick to craft. How about I solve a wall ladder? Yeah, shall we do it? Yeah, let's do wall ladder. Not yet. So basically, the transformation sequence from word begin to end word, right? So you have been given, let's change the color to yellow now. So you have been given begin word, and end word. Alright. So basically begin word is hit and their end word is cog, right? So you need to find the shortest transformation, right? So whenever shortest comes into mind, you straight away put BFS somewhere in your mind, right? On the corner of your brain. So what I can think of here is this hit for H. I have 26 options. I can choose A, B, C, D, E, F, whatever the string that I make new. If that is either, if that is there in my list, right, then that becomes. So basically in hit, uh, and it should be same. No, it should not be same basically. It should be there in my list. I'll just add it to because there could be that like after that you make something else, right? So you have to reach to cog, right? So there might be hit and kit and so you need to form cog, right? Basically, so for hit you have so you directly don't have anything for you have cog there, but from hit where you will go from hit. So from hit you can change each character. Basically, you can it look for all of these, but what is there? There might be it might also be there, right? If it is there in this, you'll form it first, right? So basically, at every time you can change one character. It is there, let's say, then it is there in the list. Then after that, after it, there is uh, eat, right? Then you change it. Then there is CET. Then you change it to CET. Then CET. Then Coq. So basically, you can understand that for each character, you have 26 options, and whichever kind of takes you to the minimum one, right? That is your number. And if you have already kind of reached that, you don't need to make that again. So that will be your the other thing, right? So it's plain BFS. Okay. Set string visited is equal to new has set, right? Q string Q is equal to new linked list, right? And level is equal to 0. And then what else? Nothing, right? So Q dot add begin word, right? While Q dot size is not equal to 0. And size is equal to Q dot size. For and I is equal to size plus string at is equal to Q dot full for care and I int j is equal to 0, j less than at dot length j plus plus. For each character you have 26 options. K plus plus char switch k plus a plus k, and then string 2 is equal to at dot substring everything beside j minus 1 some j which will be nothing ch plus ch plus at dot substring j plus 1 0 plus j plus 1 to at dot length, right? Now if visitor dot continues to false and word set dot contains to q dot add to, and then you add it to visitor dot to level plus plus return minus 1 if at not equals the word return level and set string is equal to word set is equal to word set word list. Basically, these are the levels and answer plus 4. So start level from node. This will find the that's weird. But yeah, whatever. Yeah, cool. Easy problem. Solve it multiple times. Yep, that's it, guys. Now I'll say thank you.